All right, here we go again, boys and girls. This is assignment 3. Again, we're dealing with sigma notation, which are summations of multiple number sets. Because we've already gone through this with the last assignments and the last couple assignments, I'm going to kind of start speeding up the process. Again, if I go over something way too quickly, or if you just don't understand what I did, make sure you let me know about it, like you asked in class or something like that. Make a note on it wherever you do your assignments, and I'll hopefully clarify what I'm doing. All right, so here we go. Number 1, again, is the sum of x. So x straight up is 3, 1, 2, 8, and 4. So the sum of x is 3, 1, 8, 2, and 4. 3, 1, 8. It doesn't make any difference. 3, 1, 2, 8, and 4. 18. Okay, x times y, again, you take it element by element. So the first x times y would be the 3 times 1. The second x times y would be the 1 times 7. The third x times y would be the 2 times 3, etc., etc., etc. So we have 3, 7, 6, 16, and 36 as the x times y's. So now that I have those inside answers, I can go ahead and add those up. Next, I have the sum of y squared. So the y squared is on the inside of the summation, as opposed to number 4, where you're taking the sum of y squared. So there's two different things. There's the sum of y squared, and then there's the sum of y squared. So they're two different things. So the sum of y squared. So the first thing I need to do is take the y's and square them. So 1 squared, 7 squared, 3 squared, 2 squared, and 9 squared. So those are the y squareds, and now I'm going to be taking the sum of those y squareds. Okay, so as I was kind of implying, number 4 is a different problem. So here I need to take the sum of y squared. So I need to take the sum of, change colors here, the sum of y, which is 1, 7, 3, 2, 9, the sum of y which is 22, the sum of y squared. Two different things. All right, number 5 is back to normal. This is, you add the insides, so x plus y. So the first x plus y is the 3 and the 1. The second x and y is 1 and 7. Third, fourth, and fifth. So those are x plus y's as you go down. So I get the inside answers, and then I add them up. Again, the last thing that you usually do in a problem is actually do the summation itself. All right, so I'm going to start with this. So what this is x sub 3, so that's the third number of x, times the sum of x squared. So the sum of x squared. So what I need to do is I need to square the x's. So 3 squared, 1 squared, 2 squared, et cetera, et cetera, et cetera. I need to take those x squared. So that's 9, 1, 4, 64, 16. So this is 2 times 94. So 2 times 94, 188. All right, so again, if I did number 2 correctly, the sum of x, y should be 68. The sum of x, if I did number 1 correctly, is 18. So 68 divided by 18, 3.777. Notice how the next 7 rounds to 7, so that's 8. 4 decimal places, round to the 4 decimal places. Next, x sub 2, that is the second number of x, so that is the number 1. X sub 3 is the third number of y, which happens to be the number 3, inside of the square root. So I need to square root 1/3. Again, make sure you use parentheses. Square root 1/3. Because again, if I take the square root of 1 divided by 3, it's not going to do the same thing. Square root of 1 divided by 3 tells the calculator something wrong. So again, you have to put the entire 1 divided by 3 inside of this square root, so that is obtained by using parentheses. Anywho, the square root of 1/3 came out to be 5.77. The 5 rounds the 3 up to a 4. So 0.5774. The sum of x, if I did number 1 correctly, is 18. The sum of y, which I did right there, the sum of y, if I did that problem correctly, came out to be 22. And then the x sub 5 is the fifth number of x, which is the number 4. So the top is 18 times 22. And the bottom is 4. So 396 divided by 4 comes out to be 99 straight up. Okay, the last problem, which I am going to try to step through one more time. The first problem that I'm going to try to accomplish is the sum of x squared y. So this is going to be the sum of x squared, so that's 3 squared times the y. Next one is x squared times y. The next one, x squared times y. X squared times y. And again, where I'm getting all of these numbers is the x and the y's. I'm just going through these number sets. So I'm just taking one at a time. So that one was my fourth answer. So it was the 8 and the 2. So x squared times y. That's x squared y. Okay, so that's where I'm getting my numbers and how I'm kind of obtaining my results here. So 128. And last but not least, x squared, this is the 4 and the 9, x squared times y. So 9, 7, 12, 128, and 144 is 300 straight up. Okay. The next is going to be the sum of xy. The sum of xy, and I believe I probably did that already in one of the problems. Yeah, number 2. Number 2 is the sum of xy. And so number 2, I should have paid attention, is 68. Okay, so what am I doing to that sum of xy? Well, I'm taking that sum of xy, aka 68, squared. And then what am I doing with the sum of xy squared? Well, I'm taking that sum of xy squared and I'm dividing it by 5. $924.8. So simplifying my numerator is now 300 plus 924.8. Okay, so I'll just put that together pretty quickly here. And so that's 1,224.8. That's the top, that's the numerator. The denominator is 5 minus 1. And then don't forget that the whole thing is in the square root. So 1,224.8 divided by 4 square root. I can do this all in one step. Okay, similarly how I did number 8. Similarly how I did number 8. So here we go. I have the square root, okay, of multiple things, like arithmetic is going on the inside, so use parentheses. 122.4.8 divided by 4, and that's what I want to square root, so I close down in parentheses, and that should be it. 4986. Okay. Give it a try. All right. Back side, or other side. We have write the given percentage as a decimal. And so what this is an effort to understand percentages and decimals, decimals and percentages. So a decimal, or excuse me, a percentage, like 25%, I'll write it right here, 25%, okay, is the number 25, which technically has a decimal right there and a bunch of zeros. So 25%. So when I have a percentage and I need to turn this into a decimal, what you do is you take it and you move the decimal 2 places over here to the left. So you make the number a smaller number in essence. So 25 becomes 0.25. That's what the decimal is. So 93, for instance, move it 2 places, is 0.93. Zero inject zeros, whatever I meant to say, is still 0. 0 is still 0. 100 is now 1. The decimal is dropped right there, and then there's zeros to follow. Okay, so it's just 1. %, move it 2 decimals, 0.14. Okay. write the given fraction as a percentage. So 3/4, 3 divided by 4 is 0.75. And then you just do the reverse process. So this is a decimal right here. Okay, so to turn it into a percentage, instead of making it smaller, you make it larger. So you move the decimal 2 places to the right. So this would be 75%. Again, most of the problems after this chapter, we are not writing things as percentages. Instead, just pretty much stick with the decimal, stick with the decimal, stick with the decimal. Don't write something as a percentage. I understand that a decimal and a percentage are the same thing, and we have to kind of recognize that. All right, so what do I want in this problem right here? This is 0.75, which is the same thing as 75%. 3/5 is 0.6. So again, moving that 2 decimal places. So when I move this one 2 decimal places, notice it that it gets moved, and there's this kind of like blank spot right here. Blank spots are filled in with zeros. So 0.6 is the same thing as saying 60%. So that's kind of how that kind of shakes out here a little bit. Okay, 20 out of 27. So 20 out of 27, 20 out of 27 is 0.7407. Move that 2 decimal places. That's 74.07%. 18 out of 19. Still round your decimal, is 94.74%. 15 out of 15. 1. Move that decimal 2 decimal places, that's 100%. All right, how to use a percentage. How to use a percentage. You have a decimal, or you have a percentage, and you want to use it. All right, so with this last section too, if you don't have a percentage and you need to make a percentage, like you don't have one and you need to make one, you divide. You divide to make that happen. Right? Example would be 18 out of 19 kids love statistics. 18 out of 19 kids. What percentage is that? Well, you don't have the percentage, so you create the percentage. And so 94% of the kids like statistics. So if you don't have a percentage and you need to create one, you divide. If you have a percentage and you want to use the percentage, you multiply. And that's what this section is. All right? So what you do is you first need to understand what the percentage is as a decimal and use the decimal version. Don't use the percentage. All right? So for instance, the percentage is 25%. So that's 0.25. Again, use the decimal. Okay, so the percentage is 25%. Now, what am I applying that to? 60. How do I use it? I multiply. So that is 25% of 60. 25% of 60. I'm using the percentage, thus I multiply. So here we go. 25% of 60. 32% of 94. Ooh, 4%. Okay, think of 4%. So 4%, move the decimal 2 places. So 4% is not 0.4, it's 0.04. So think about that. Like it was 4, and then I moved it 2 places. So take the percentage as a decimal, and then use it. Exact. So 4% is 0.04, not 0.4. 0.4 is technically 40%. 0.04 is 4%. So two majorly different things. Okay, I digress. So 4% of 73. And then 78% of 12. And then the last 3 problems are word problems in which you have to just kind of identify, like, are you making a percentage? Are you using a percentage? What's going on? All right, so number 26. There are 128 days of actual school days in the year. Student X was absent 9% of them. Approximately how many days did student X move? So are we making a percentage or are we using a percentage? We are using a percentage. We already have one. We have 9%. And what are we doing? We're applying that to 180 days. So if a student was absent 9% of 180, that will give you the number of days. It'll give you the 9% of 180. So 9% of 180. This student was absent 16.2 days. There's 85 days of actual school in the first semester. However, student X has a strict 13-day absent policy. What is the maximum absent percentage of the first semester? Can a student be absent and not be dropped? Okay, this is applying to our absent policy, where 12 you're okay, 13 you're dropped. So this is somewhat of a trick question. So how many days can they be absent and still be not dropped? Well, that's 12. They can be absent 12 days. Now, what is that as a percentage? So now I ask, do we have a percentage, or are we going to use a percentage, or are we going to make a percentage? We are going to make a percentage. That is what the question is. What is the maximum percentage? Question mark. We don't have the percentage, and we need to make one. So we can be absent. This implies that I can be absent 12 out of the 85 days. I can be absent 12 out of the 85 and be okay. So 12 out of 85 sorry. I can be absent 14.12% of the days. Student X is taking a test and is concerned about his or her grade. There are 23 questions on the test. He or she wants an A, a 90%. How many questions must he or she get correct for an A? Assuming that's the question credits. So, wants to get a 90%. There's 23 questions. So that means we need to get 90% of those 23 questions. Excuse me. Do we have a percentage or we need to make a percentage? We have a percentage. We want to get 90 correct out of 23. So 90% of 23. 20.7 questions they have to get correct. So again, partial credit or something. They would have to get 20.7 questions correct. Technically 21 questions if they're full questions. Anyways, I digress. That is percentages, using and making percentages. I believe in Unit 1 there are 5 assignments, something like that, 5 assignments, something in that ballpark. So we are kind of coming to the end of Unit 1. Unit 1 is a really short unit. So be up to speed, make sure you're getting all of your assignments done, and don't put them off till later because, as I said, the test is coming right down the pipeline here, and early in the year, it's in your best interest to get your grades really good right away. I don't want anybody to be playing catch up when it comes to grades. So make sure you're getting your stuff done. Make sure you're understanding the stuff. And if you're not understanding it, take care of it now. Ask questions in class. Participate. You are the determining factor of everything as far as grades and everything. So you are the deciding factor. How hard did you work to get what you need to get done? Okay? So anyways, this is percentages. You can watch this video 1,000 times if you want to. It's all good. Have a good day. If you have any questions, let me know in class.